Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is minimum common value. So here we are given two arrays which are nums1 and then nums2, and then they are sorted in non-decreasing order. And then we need to return minimum integer common in the both arrays. Suppose let's take this particular example. Uh, if we take this particular example, there is 1, 2, 3 and then 6, and then for this it is going to be 2, 3 and then 4 and then 5. So for this particular two arrays, there are common integers which are 2 and then 3, 2 and then 3. Out of all these 2 and 3, we need to return the minimum integer present in the both the arrays. So we need to do that. So let's take this particular the same example, which is 1, 2, 3, 6 and then 2, 3, 4, 5. So suppose we want to find the minimum value which is present in common arrays. Suppose let us think that we have only one array, which is this, and then we need to find the minimum element. We'll just see the first element and then we'll return 1 as our answer. Why? Because it is it is in non-decreasing order. That means like it is it is in non-decreasing order. So the numbers might be increasing or the numbers might be same in the next iteration. And then when we compare for this one as well, there will be only left element which will be minimum, so we'll return this particular left element. But when we come to both the arrays, considering both the arrays and then common between them, we'll check, we'll see the different approaches. Suppose let's say we have 1, 2 and then 3 and then 6 and then 2, 3, 4, 2, 3, 4, 5. We'll take a map and then we'll mark 1 as visited and then 2 as visited and then 3 as visited and then 6 as visited, and then the elements which are present in this particular array is going to be marked as true. And then again we'll come to here in this particular array and then we'll see whether this particular 2 is visited or not from this particular array. Yeah, if it is, yeah, this is visited, so we'll say this particular integer is present in both the arrays, we'll return this particular number. And then after this is not, let's say this number is not present, then we'll move to the next iteration which is 3. So like this we can solve via using map. So if we come to the time and space, the time is going to be big of n and then space is also going to be big of n. Why? Because we are taking extra space. Let us consider another approach. As it is given that the arrays are in non-decreasing order, that means it is in sorted order. Suppose let's say we have 1. We need to check whether this particular 1 is present in this array or not. So we can do via binary search. We'll take 1 and then we'll see whether 1 is present in this array or not. We'll see it is not present, so we'll move to the next iteration and then 2, yeah, we'll see and then we'll get to know that it is present, so we'll return this particular 2. And then one more approach, for this particular case the time complexity is going to be n log n, and then space complexity will not be, it is going to be big of 1 itself. Why? Because we are not taking any extra space. And then one more approach is, instead of binary search we can do the linear search. That will take n square, so that will not be the better approach. That is, if those are the approaches. Like if we consider map, we can use we can do via map and then we can do via linear search and then we can do via binary search. And then what is the optimal solution? Suppose let's say both are in non-decreasing order. That means we can use 2 pointers. Suppose let's say this one, we'll check with 2. So this one is less than 2. That means we can move to the next iteration and then we'll see we'll compare 2 with 2. 2 is same as 2, so we'll return this particular number. Suppose let's say 2 is not present, and then we have 3. We'll say 2 is less than 3, so we'll move to the next iteration, and then 3 is present. Suppose let's say 3 is not present, then we'll compare 3 with 6, and then we'll move to the 4, and then 4 with 6 we'll move to the 5. So whenever we meet up the elements which are lesser than the current element in the other array, so we are going to increment so that we'll get to the nearest value which is present in the particular array. So that is how we are going to do. So let's see the solution for this. So for this approach, the time complexity is going to be big of n, and then the space complexity big of m plus n, we can say. Why? Because it has two arrays which will be of m and n size. So we might be traveling both the arrays. So it is going to be big of m plus n, and then let's take left index as 0 and then right left index 2 as 0, and then we'll check whether this particular nums is less than or less than nums 2. At this particular time we need to increase the left index, like this one. If we compare 1 and 2, then we are going to increment this, and then we are going to move towards the next element, and then if both the elements are same, then we are going to return the nums, and then if nums2 is less than the nums1, then we are going to increment left index. Suppose let's say the common element is not present, then we are going to return -1. Yeah, the time complexity is going to be big of m plus n, and then space is going to be big of 1. Yeah, that's all for this video. Thanks for watching the video.